Assalamu alaikum. Welcome to this MATLAB tutorial. Today I am going to teach you how to design load frequency control model of the power system using artificial neural network in MATLAB Simulink software. Friends, the first requirement to apply the artificial neural network as an intelligent controller is that we must have the conventional load frequency control model of the power system. For your convenience, I am considering the simple load frequency control model of the power system as shown here. On this topic, I have already made the video, namely how to design load frequency control of thermal or hydro power plant using transfer functions in MATLAB Simulink software. Therefore, if you can watch this video and apply the ANN controller in this model, then this model can be used for your master degree research or one of the PhD research objectives. Now just look at the model. It may be observed that in this model we are using the PID controller. Friends, some researchers have used the PID controller in the feedback loop as shown here, whereas some researchers have used the PID controller after the error as shown here. Therefore, in this video, I am using the PID controller in this position for the better results. Double click on this PID controller block. You can see the parameters of the PID controller are 50, 30 and 10 for P, I and D respectively. Let's check the voltage graph using the PID controller at these values. Run the simulation. In the previous video, as mentioned few moments before, we discussed that its response was satisfactory, which was obtained after the several attempts. Now let's check the response of the PID controller when it is connected in this position. Run the simulation. You can see when PID controller is connected in this position, its response is extremely poor. It means that we need to change the parameters of the PID controller again. To do this, double click on this PID controller block and put the values of P, I and D as 1, 0.25 and 0.28 respectively and press OK. Now run the simulation to check its performance at these values. You can see this time its response is much better. Now let's learn how we can replace this PID controller with artificial neural network based controller. As we know that ANN needs the input and output data of the PID controller for its successful training. This requires the shifting of PID controller input and output data from the Simulink model to the workspace. For this purpose, just go to Simulink library, then go to sync. You can see here two workspace block is available. Take this block and bring it in the model. Connect this block here. Double click on this block. In the variable name, write input because this is the input to the PID controller. In the save format, click on array and press OK. Similarly, to get the data for the output, just copy this block and paste it here. Connect this block here. Double click on this block. In the variable name, write output and press OK. Now run the simulation in order to shift the data from the Simulink model to the workspace. Now come to command window. You can see in the workspace section we have input as well as output data. Friends, it may be noted that input and output have extremely large data consisting of around 200,000 of the samples. This data is very large. It is better to reduce this data so that we may perform ANN training easily. To do this, just select this whole model, copy it. Now open new blank Simulink screen by pressing Ctrl+N and paste it here. Now save this model in any folder with any name where you want. Change the simulation time from 10 seconds to 20 seconds. And run the simulation again to shift this input and output data. Now come to command window. You can see this time input and output data is reduced to 609 samples, making it easy for us to perform the ANN training. As we have received this input and output data, Now we can perform the artificial neural network training by using the MATLAB program or GUI tool. Just look at this MATLAB program which is used to perform the artificial neural network training. Friends, I have already made the videos on artificial neural network series to understand its basic with the title How to Implement Artificial Neural Network in MATLAB Simulink. This ANN series consists of 4 parts. Therefore, it is my strong suggestion to watch those videos first for the better understanding of the artificial neural network training. Friends, don't be confused with this code. It is very easy. This program has the advantage that this code remains almost same for any type of the problem. Therefore, for your convenience, I have shared the link in the description section. You may download this code from there and directly use it for your training. Now let's start the ANN training. To do this, just click on this run button. It will automatically start the ANN training. To get some idea about the successfulness of ANN training, click on this regression button. You can see its regression value is 0.8701. As we know that the criteria for the successful ANN training is that regression must be equal to 1. Therefore, it means that our ANN training is not going to be successful. Therefore, stop this ANN training here and close both windows. Let's try it again. Maybe this time it provides the good results. You can see this time we obtained same result. Therefore, stop this ANN training here and close both windows. Friends, there may be many reasons for this poor performance. One of the reasons is that our PID controller is not properly tuned, due to which its data is not uniform. Therefore, its response can be further improved by using the PID tuner block available in the MATLAB Simulink software. On this topic, I have already made a video, namely how to design PID controller in PID tuner using the MATLAB Simulink software. Therefore, if you want to know the details of PID controller tuning, you may watch this video. To do this, just double click on the PID controller block. Now just click on this tune button. It may be noted that when you will click on this tune button, the MATLAB automatically opens the PID tuner and sends this graph directly to PID tuner and automatically designs a tuned controller response of the voltage graph. You can see the PID tuner has brought the original block response in the PID tuner. Furthermore, at the same time, it has automatically tuned the voltage response with minimum overshoot and smaller settling time. Suppose now you are satisfied, just click on this update block to send the updated parameters of PID controller to Simulink block. You can see now the parameters of PID controller are automatically updated. Just write here 100 and press OK. Now run the simulation again to see the tuned response. Friends, it may be observed that this time still PID controller response is extremely poor. Maybe we have done something wrong. Let's do it again by repeating the same procedure. Now in the response time slider, move the slider and bring it at the faster point. Similarly, in the transient behavior slider, move the slider and bring it at 0.6. Now click on this update block to send the updated parameters of PID controller to Simulink block. You can see now the parameters of PID controller are automatically updated. Just write here 100 and press OK. Now run the simulation to check its performance at these values. You can see this time its response is much better. Now let's perform the ANN training again. To do this, just click on this run button. To get some idea about the successfulness of ANN training, click on this regression button. You can see its regression value is 0.88191. As we know that the criteria for the successful ANN training is that the regression must be equal to 1. Therefore, it means that our ANN training is not going to be successful. Therefore, stop this ANN training here and close both windows. Friends, it means that our system data is little bit complex and ANN is not being able to perform its training due to smaller data. At this stage, we have to do some other steps in order to perform the successful training of the ANN. Friends, in some research papers, the author used derivative function to take the derivative of the input signal going towards the PID controller. In this case, the input for the ANN training will be consisting of two signals, making it more convenient for the ANN to obtain its training successful. Let's try this option. To do this, just go to Simulink library, search for the derivative term, take this derivative block from here and bring it in the model. Now we need multiplexer block because we have to combine two input signals. Therefore, take this multiplexer block from here and bring it in the model. Now connect the derivative block here. Similarly, connect the output of the derivative block to one port of the multiplexer block and connect the other port here. Friends, it may be noted that we need two inputs for ANN training, not for the PID controller. Therefore, the input to the PID controller must be 1. Therefore, we need demultiplexer block to get the single input signal. For this purpose, take this demultiplexer block from here and bring it in the model. Connect the multiplexer output to the demultiplexer input and connect the one output port of the demultiplexer block to the PID controller as input. Now connect this workspace input variable here to get the two input variables as data. This is the overall arrangement of the modified model. Now run the simulation in order to shift the data from the Simulink model to the workspace. Now come to command window. You can see in the workspace section we have input as well as output data. Look at the input data. You can see now this input variable consists of two signals consisting of 609 samples each. Now let's perform the ANN training again. To do this, just click on this run button. Friends, you can see 10,000 iterations are successfully completed. Let's check what is the regression curve for these 10,000 iterations. For this purpose, just click on this regression button. It may be noted that regression is equal to 0.99712, which is very close to unity. As we know that the criteria for the successful ANN training is that regression must be equal to 1. Therefore, it means that our ANN training is almost successful. Now close these windows. Look at the workspace section again. You can see here net block is available, which is the trained artificial neural network. Now we have to save it. First, we have to save it in any folder for our reference so that whenever we need, we may use it. To save it, just right click on this variable. Click on Save As to save it in any folder of your choice and with any name of your choice. Now we have to shift this trained ANN model from the workspace to the Simulink. For this purpose, we have the MATLAB command known as gensim. Therefore, write this command and press enter. You can see the MATLAB has shifted the trained ANN model from the workspace to Simulink. Now take this trained ANN block from here and bring it in the Simulink model. Remove this PID controller and demultiplexer block from here. Connect the ANN based controller here. This is the overall arrangement of the modified model with the ANN based controller. Friends, at this stage our model is completed. Now we can run the simulation to check the performance of the ANN controller. Click on this button to run the simulation. You can see the artificial neural network based controller has successfully provided the desired output voltage. It may be noted that the voltage has some variations at this point. Therefore, if you want to train it again, you can train it in order to get further improved response. Otherwise, this response is also acceptable. Friends, in this video I have discussed how to design load frequency control model of power system using the artificial neural network in MATLAB Simulink software. This model can be used to complete your master degree or PhD research objectives. Furthermore, you can even write research paper from this model and you can publish it in any journal. By repeating the same strategy, the artificial neural network based controller can be implemented for any model related to any field in order to complete the master or PhD research. That's all for today's tutorial. If you like it, then don't forget to like my video, subscribe my channel and share this with all your friends so that they may also get benefit from this video. Thank you very much.